To the second session of our symposium. In this session, we have two valuable speakers, Professor Kopacek and Professor Bauer. Please welcome Professor Peter Kopacek from University of Vienna, Vienna Institute of Mechanics and Mechatronics to speak on social and ethical aspects of the robots in production 4.0.
Thank you very much. I hope you had a reasonably long, and good coffee break. And my goal is, in the next 20 minutes, to give you a completely unscientific presentation. I am emeritus, and old professors get always a little bit philosophical, and I started to deal with roboethics approximately 6 or 7 years ago, and I will try to give you first introduction in ethical and social aspects of robots in production 4.0. That's definitely not new. You know it from the previous presentation. Production 4.0 is not new. We had it in the late 90s, and it was called agile manufacturing. Now, yeah, think a little bit back. IT in the late 90s, we had definitely not the necessary hard and software available. Yeah, you have here, I think that was mentioned by my previous colleagues. You have huge data cemeteries, okay, computational power, and I think Andre told you a little bit about the so-called smart factories. What are the advantages of such smart factories? Allow to produce goods in a reasonably small lot size, and as you have recognized, production goes more and more hectic. And if you have such a smart factory, probably you can make changes in the last minute, I hope so. And the smart products are uniquely identifiable, may be located at all times. Is it an advantage or a disadvantage? That's a question. Knows their own history and the current status. Okay, that's very good, because I will come back to end-of-life management. And we had always in end-of-life management the problem, how old is this part and how long was it working? Yeah, that's a trial to categorize the currently available robots. What is of interest for production 4.0? Industrial robots, especially the good old dual arm robots. What is of interest, what could be of interest in the future? Humanoid robots, and some kinds of mobile robots. These here are robotic dreams currently. Yeah, we had also, I think Andrew mentioned it also, so-called MIS, multi-agent system, nothing to do with CIA or KGB in former time. These are cooperative, terribly cooperative industrial robots. And the goal was, these robots are terribly intelligent, and for example, such a multi-agent system get a common task. For example, assemble a car. And they should be so intelligent that they are in the position to divide this whole problem in subtasks until 1, 2, or 3 robots could solve this task. Yeah, that means we are on the first step on this dream, and we have now distributed network systems. Yeah, that's now a little bit about roboetics. The usual question, could a robot good or evil? My answer is very simple. A robot is programmed by a human, and according to the program, to the programmer, the robot can be good or evil. Could robots be dangerous for humans? That's also a story. According to the statistics, started in 1985, there were only 2 accidents with robots and humans. This is necessary for robots. This is necessary for roboetics. Until 6 years ago, this field was dominated by colleagues from here. Yeah? And we started 6 years ago to bring a little bit technology in this community. Yeah, you know Mr. Asimov. It's a basis of the roboetics. But I like governmental employees, and you can make Asimov for governmental use. A robot may not ensure an authorized representative of the government. A robot must take and so on and so on. And the best I find, a robot must pretend his own existence at any price, because a robot is terribly expensive. Okay. And I had a very nice colleague, Universidad de Ciencia in Italy, and he has here, that's a definition. Yeah, some examples. You have here industrial robots, mobile robots, humanoid robots. What are the benefits? These are only examples. Increased productivity, loss of low-tech workplaces. I will come back a little bit later. Ethical accommodation, education, mobile robots, and humanoid robots. Yeah, we have here some, that's, for example, closer connected to my previous slide. Unpredictability of robots' behavior software. Sometimes it's a bug in the software. Okay. Yeah, and for production 4.0, we need highly networked robots. All is connected by the internet. You know, in robotics, we are always copying the buzzwords from IT. We had personal robots, we had cloud robots, and so on and so on. With a time delay of 3 to 5 years. Yeah, what's going on in so-called research in robotics? Economy, psychology, position of humans in the control hierarchy, okay. Law. Think always that some technical advances cannot be implemented, for example, self-parking car. It was ready 7 years ago. Yeah? But the problem is always, if your car touch another car, who is responsible? You, the producer of the car, the producer of the parking system. Yeah. And that's similar here. Okay, environment, I will come back a little bit later. And for service tasks. So, that's a summary of roboetics. These are the goals of roboetics: avoid conflicts, work for a safe future, and protect the environment. Open questions. Will be robots real partners for people? My personal answer is yes. I'm not very young, and probably in 3, 4, 5 years I will have my personal robot at home. And I'm soccer freak. I have a TV at home, but I'm never watching. But in 5 or 10 years, I will sit to the game Rapid Austria, and my robot is sitting aside of me, and Austria shoot a goal, and I'm exciting, and my robot is also exciting, and then I ask my robot, please bring me a glass of red wine. And my robot will look at me and will say, dear old guy, you know the medical doctor have forbidden for you red wine. I can bring you a mineral water, and you have only the choice with or without gas, and with or without ice. Okay. Yeah, social aspects, that's definitely not new. The main trends: digitalization, highly networked production processes. I'm waiting for production 5.0, or can it now. Good, okay. I'm looking for production 5.0. The problem is, for production 4.0, we need operators with a special education or special training. Production 4.0 is not static. Developments are very fast. And this must be updated continuously. And I'm always a freak of SMEs. What they are doing with production 4.0, I will come back a little bit later. Will we have, like 1985, when we introduced the first hippopotamus robots, in industrial production, will we have the army of unemployed, the manless factory, and so on and so on. You have here what will be the role of the humans in production 4.0. Deciding on the best solution from a number of alternatives, but we learned from one of my previous speakers, here, probably the computer get so intelligent that it's possible to decide or to find new alternatives. Managing unforeseeable events or deriving new and creative ideas from the experience. So, we have here social aspects of robots in production 4.0. They are definitely similar to this coming with the introduction of robots in manufacturing automation in the 80s, armies of unemployed, the unmanned factory, robots as job killers. My idea is you need a higher education of the operators for the system and increasing the production output, quantity and quality. In 1985, this works. Yeah? Product output was increased, quantity and quality. For example, some automobile producers. Probably it will be true with production 4.02. I have only some questions on the heroes of production 4.0. Simple question. What are the costs of installation and maintenance? Because production 4.0 is a very, very complicated software. And if you add one sensor, you have to include this sensor signal in this software cemetery. Yeah? What is the return of investment? Makes it sense in some SMEs to deal with production 4.0? And my recommendation is tailor-made education offers for the future operators of production 4.0. Some concluding remarks. What are we doing? As you know, I had together with my older son since 1998 a hobby, end-of-life management. We had in the first presentation. We did the same 1999, but without any theoretical background. Disassembly cell for printed circuit boards, disassembly cell for mobile phones, disassembly cells, semi-automatized. That was a little bit end-of-life management, and believe me, it's coming back now. Because it was mentioned, I think by Andrew, raw materials. We had, always my older son and myself, we had this very nice idea 10 years ago to extract from electronic scrap rare materials, gold, silver, platinum, yttrium, niobium, and so on and so on, And in the framework of two EU projects, flagship projects of the European Union, we developed some 2 stationary plants and 1 mobile plant. Yeah, because the problem is always SMEs have electronic scrap, but not an amount. They have 100 computers. Yeah? That's nothing. And we developed a nice track with 2 containers, and this track is coming to the SMEs. Naja, coming back of this assembly, chemical processes, I learned a lot in the last years about chemistry, are always very time consuming. And for reducing of the input in this chemical process, we make a disassembly, because usually on a printed circuit board, 95% of the material have no material what we want. Okay. Now yeah, let's have a look what's going on. Thank you very much.
Professor, please stay with us. Please stay with us. We invite Professor Semra Birgün from Beykent University to present the plaquette. Please welcome Professor Jorge Bauer from University of Vienna Technology and Technological University of Buenos Aires, Argentina, to share his experience on computer-integrated manufacturing, intelligent manufacturing systems, or multifunction intelligent factories to Industry 4.0 with automation.
Thank you. I lose. I am really happy to present and share with you this scientific event. Here in Vienna, as an Argentine and Austrian academic. When I was young, the city of Vienna was the city of my parents. In the last year, it's were all my city. First, I would like to apologize you for my poor English. Although I have been reading technology books many, this language for me is usually not good. I normally speak in German or Spanish and have very difficult to speak to you in English. I would like to thank any word for this opportunity, especially Professor Durabasha, who were my doctoral brother, to give me this opportunity to present you some ideas and concepts which we work together. Professor Durabasha and I were the disciple from Professor Osana. Professor Osana taught us very much that only technology and engineering. For all as us, we have a real master in Professor Osana, and he is now present more and more. It's a great honor to mention also Professor Kopacek, who were my second doctor father. With Professor Kopacek, we have a passion of real hardware. I think real hardware is for us mechanical iron piece, and now we speak very much from mechanical, mechatronical parts. And in the last time, we have very present the ethical aspect from robotic and automation. We now call Professor Kopacek. Hey, my drill. Bueno, the idea how were to present the evolution from automation in another concept we speak from Jidoka. To project in the future is not a simple way. In the south of America, we ask for this, we have a break. Now we have an engineer method to see the future. We project it with some curves. And can see that the evolution is an evolution in exponential form. All experts in the goal in the 5th industrial revolution, the goal in the will will be, especially in Europa, defined target Industry 4.0, passive and intensive use of college-generated computer-aided technologies. In that sense, for Industry 4.0 is for us essentially an evolution of the computer-aided integrated manufacturing concept called in the 17 years the factory in the dark or the factory without worker. This concept evolution to intelligent manufacturing systems from Professor Kopacek in the last years. And then Professor Osana speak of a new concept that were multifunction integrated factories. In this sense, for us, Industry 4.0 fundamentally is the evolution from CIM, and not a real, total new concept. An important for us to have in mind is, in this point of view, in a traceability conception, will keep to holistic perspective, begin to the doctoral investigation, and is your way to see most important characteristic we analyze and study linked with Industry 4.0. We appraise in that last time a new quality leap in the factory that the concept of automation goes and bursts more strongly as the idea of automation production. Automation production refers, in other words, to intelligent automation, with the methodology units integrate in the production. guarantee not only 100% of parts according technical products specification, and also automatic elaboration of associated protocols. According to the International Labour Organization, automation is the replace of human works with machine. In this way, we can say it is an extremely dynamic and broad definition. It is also to consider it as something that has been used as automation unit only a few decades ago, today not longer identifies but full automatic. Today, this sense is much too deep in another much to description to not waste parameter of automation. Replacing of human works for machine are much more demanding. This thing that is according to tell my student the good news of study of automation engineering. Creative works is not expected to live in this field. The concept of automation production, intelligent automatization has the origin in the lesson of Jidoka. According to Jidoka principle, the product process immediately turn off when the productive defect arises. If on this word principle, the automation criteria built up. Jidoka principle together with just-in-time principle are the two most important bases of the Toyota production system. This idea was based on the invention of independent reactive loom. The loom stopped at once meet that's a building machine with a building machine part. So, not defect product was made and faculty produced was completely avoided. In few words, automatic was defeated at the level which the human labor is replaced with machine. This concept generates a main question for the social and ethical science that is analyzed in the meeting from multiple presentations. The question is, Industry 4.0, which automation is the way of the work or a better work organization for all? I hope that this question will also be discussed with passion tomorrow in the round table. At this sense here, I present only my personal opinion. We should not expect that good results will automatically regenerate, neither automatically. Good results need much work from everybody. In another translative approach, where we return to the concept that integration is much of more than the sum of the parts, we can like autonomous production cells with Internet 4.0 in a wider schema. In this picture, take us into the subject of the necessity and possibility of telepresence and teleoperation. In my personal life, I link it since approximately 20 years. I start me to ask myself how I bring the laboratory of micro and nanometrology from TU Wien Karlsplatz to Buenos Aires. Specifically, the problem was about using the metrology units in Buenos Aires while the colleagues from AUM, which are there through hours, continues to using it in Vienna. Today, we use different software and hardware and advance in a real telepresence environment. At last but not least important, I want to talk about the strategy concept in which we have worked during the last year with our TUIN team. In the context of Industry 4.0, we are monthly metrology and have a strategy plan passed in 3 columns containing the 3 laboratories that enclose completely each other. We have much to say about South American node and the different subnodes, but we hope you can visit us and see if with your over aids. We can see the 3 columns of our laboratory. The main and middle parts, we can see the Automation lab. A lab we have metrology and productions together. Another column is the traceability with the nano and metrology lab. And the 3 columns we are now construct is a laboratory for the new technologies of metrology. Conclusion. For my personal perception, Industry 4.0 not only needs analysis and technology development to grow in the future, but also a lot of experimentation and transdisciplinary vivid experience. The second conclusion is the central contribution of AUM as team is to participate in the development of all aspect focus of autonomous production. In other words, incorporate metrology and quality control in the automatic production as a serverless process. Personally, I think about the strength and specific are the technology aspect, the aspects associated of human subjects need, and a lot of study of collaborative works. Other conclusion, I would like to share with you that there are other possibilities to see this aspect. And in this sense, we are open to questions and many debates. Thank you very much for your attention, and I hope my problem with English were not so big. Thank you very much. Thank you.
We invite Professor Alptekin Erkollar from Sakarya University to present the plaquette.
The next, thank you. Herzlichen Dank.
Soll ich mit Ihnen Deutsch reden oder
Ja,
Englisch reden?
Deutsch
Wäre
ist
das
viel
noch
besser.
ne?
Deutsch ist
Dann
viel
Englisch.
besser oder Spanisch, aber Deutsch ist auch perfekt.
Ich kann für das Spanisch nicht sagen.
Aber Deutsch ist perfekt für mich.
Herzlichen Dank für alles, für diese wertvolle Unterstützung dieser Konferenz und für perfekte Präsentation. Lassen Sie ganz einfach die englische Sprache.
Genau.
Inhalt ist für uns genug. Thank you very much
Thank
for
you.
this valuable presentation and supporting for this conference. Thank you very much.
Dear guests, we have reached the half of the first day of our symposium. Now the program tells we have a lunch break, and we invite you to the networking and break area. Bon appetit.